Yes?
It might sound like a weird question, but how do you know that it's giving you the area of what you don't want versus what you're actually looking for?
Because the chart always tells me the area below.
Oh,
Period.
always below. Okay.
So the question wants an area that's not below something. I'm going to have to do something. So the chart's really useful, and the only way they can make it just a one sheet, two-sided, is to make it very single-minded. And then we, as the humans, got to go, I can work with this. Yes? Yes. And why does it make complete sense? Why has Jeff been getting you ready for this day forever? We answered the opposite of this question, right? So then I do 1 minus to answer the question. Doesn't that sound a little familiar? A method to the madness. All right. Some of you guys are just like, it's just madness. Okay. What else did I want to say? Oh, all right. Is everybody cool? That's beautiful. That's done. That problem is done. Do me a favor real quick. If you don't quite get this whole thing I'm about to do right now, don't worry about it. It's a little shortcut. Look up negative 0.42. Look up negative 0.42. That's all I got to say. Sorry, that was nice of me to laugh at you.
Oh.
Wow. Now, think about it. Why does it make sense? Because the area that's above positive 0.42 should equal the area below negative 0.42 because of symmetry. How important is it that you understand what I just said? Not really, because we did the problem without any of that shit. But it is a little tiny shortcut that I just want to let you know about because of the symmetry. So the area above 0.42 should be the same as the area below negative 0.42 because they're symmetric. Boogie, woogie, woogie. Every time I say that word, I got to say that in my head. So.
And it would never be like negative, right? Because
Yeah, areas and probabilities cannot be negative. Very good point. Because in a minute we're going to start subtracting shit, and you better make sure you subtract the right things so you don't get a negative number. Probably rain tomorrow is negative 20%. What? Is all the water going to just rise? It's negative rain. All right, sorry. It's not going to happen. Don't worry. So what about try to draw the situation and then try to do it, but let me see if you guys get this idea. What's the probability that Z scores between negative 3.07 and 1.08? Again, for those of you in the back, there are decimals there.
Did you technically break this problem up into 2 different problems?
Say it again, sir. You have to. Good point.
Oh.
There it is.
Wishing it was my W. Right. What's your grade in this last
So to draw this, hopefully I wasn't too big of a step. Right? Hey, don't be a pup. Now, if I look up 1.08, that's not going to be the answer, right? Is it going to be too much or too little? Too much, because it didn't stop where I wanted it to. But when I look up 1.08, what do you get? Yeah, I get 0.8599. So that's the area all the way down from 1.08. So I have how much area too much? Exactly this much area too much. Well, what area is this? Yeah, so you look up negative 3.07, negative 3.07, and you get 0.0011. You can see that?
Yes.
That's the area below that. 0.0011. So then what's the area in here then?
You subtract.
Subtract them. That makes complete physical sense. I like to point that out. A lot more math does than you realize. It has to make physical sense in many situations. This one is in your face, hopefully. It makes freaking sense. It's too much, exactly this much too much, so subtract them to get what's in the middle. So what's this going to be then?
8588.
8588. By you. Become an 8. Sorry. Yes.
So, when you mentioned earlier, you said like the negative z-score will be the same distance as like the positive one that has like anything above it.
So like the 4-2 thing, right?
Yeah.
Is that what you're talking about? Yeah. There's symmetry
So,
there.
So I think that like confuses me a little bit. Like I can't grasp. my
So
mind.
release it completely. Forget about
Yeah.
it.
So
That shortcut doesn't save. It saves like 0.7 seconds.
Okay.
But I just want to throw it out there because it's interesting.
So there's never going to be an instant.
Where you have to use it, you never have to. Yes. Do it again.
How did you think?
So what did I say? So this is too much. This area is too much area because it goes all the way. I wanted it to stop here. So how much do I want to chop off of this to make it stop there? This much. So subtract that off. So whenever I ask you, find the probability that something's between two things, right? Not two ferns, but two things. I'm going to eventually have to subtract. Right? No Zach Galtonix. That might be just for me. No, between two ferns fans.
No, I love that. That's
There.
hilarious.
How did you get the 0.8599?
Look up 1.08 on the z-score chart. 1.08. You got it? Okay. So, I don't know if you noticed. Let me see if I can do this wrong. I don't know if I fully trust what I just did, but a while back I marked feet off on this thing, and I just try to estimate. I think that door in the back seems too much, but I think it's 84 inches, let's say. It's actually, I think, 86 inches by what I did. Let's say it's 86 inches. If men heights are normally distributed, and I'm not leaving women out because I'm an asshole, I'm leaving women out because tall men are taller than the tallest women. So if I'm worried about people ducking through a door, I really just have to worry about the group that's taller on average. Is that cool? All right, I like it. So their average is 69 inches tall, their standard deviation is 2.8 inches. So what percentage of men, what's the probability that a dude will have to duck to get through that door, that they'll be greater than 86 inches tall? So if we were hobbits, we'd obviously have lower ceilings and lower doors, right? The people that hit their heads, we would hate them because like, what the hell are you doing being so tall? You're not like the rest of us. Take you out of the knees. So how can you draw this picture for me? So So this is a physical situation. We have created a door, and I want to know what percentage of men are going to have to duck or hit their heads and maybe complain. What goes in the middle? Good. I don't know why I'm shouting. Very good. Where's 86? Where's 86? Up here. Okay. And where do I shade? Above it. What do I put underneath this one? 0. How do I figure out what to put underneath this guy? It's a formula. So the problems you were doing a minute ago were all z-scores. So they were immediately ready to use the chart. I can't find no 86 in the chart because, one thing, it's not a freaking z-score. There's no reason it should show up. Take a minute. What does 86 become as a z-score? The formula is what again? Okay. So the data point that I'm interested in is 86. The mean was 69, and the standard deviation was 2.8. It's going to be pretty big, right? Yeah, dude. Now we're talking. 6.07. No, you're fine. I mean, that's pretty far up there. I mean, that's a 7-foot 2-inch dude. How many 7-foot 2-inch people have you run into in your life? Yeah, I ran into Manute Bowl. I think I talked about this already, didn't I? 7'7". Oh yeah. He was coming off the Southwest flight, and everybody that was on the flight with him said his knees were like right next to his eyes when he sat down. If you don't know Manute Bowl, he was in the NBA. He was like one of the tallest dudes ever, 7'7". Didn't have to jump to dunk, so it's really neat. Anyway, so that, do you guys get a feel for this right now? That is what? What does the z-score tell you? The number of standard deviations away from the mean. And in this case, it is 6 steps. It's a little more than 6 standard deviations above the mean. Would that height be unusual? It's way more than 2 above. In fact, is 6.07 even on the chart?
No.
What's it say though? You guys see what it says in this situation?
Use .9999.
Yeah. So if you try to look up 6.07, it just kind of gives up. It's like we ain't got that much space left on the thing. You ready? So you can use that number, because that's what the chart says, and I'm making you use a chart, so it'd be really mean, but made you do this other thing. So right here, this would be .9999. So what's up here? 0.0001. So 0.01% of the population would have to duck to go through that door. So that's fine. I'm not going to stop. I'm not going to say more about that problem. But that's just like the first little hints or the tease of a real life problem that you use this shit for. Okay. Let's do, let me see what time. Oh, good. Let's do 2 more problems and we'll head out. Next time I've got a worksheet. Surprise, surprise. So say I have a normal curve. Let's say these are test grades. Right? Let's say the mean was 71.3 and the standard deviation was 15.15. Sounds great, Jeff. Yuck. So I want to know the probability that somebody scored more than 85. So just try to do that problem. So eventually I will be able to use the chart. Why? Why will I be allowed to use the chart? It's normal. What goes in the middle? And then where's 85? It's going to be up here somewhere. And then I want greater than that. So now the picture should help me. I already know. Should the answer be very large probability?
No.
No. Don't tell me the answer is 99%. I'm like, how the hell you fit 99% in that little area? So what's my very next thing I do?
Get Z-score.
Yeah, I got to figure out this guy's Z-score so I can use the Z-score chart. Makes almost too much sense, yes? Good, so 85 minus 71.3 divided by 1515. I don't know what balance is. A little less than 1. 0.93. I don't know.
0.8159.
8.5.
Or
So,
no,
wait.
0.9043, and then I looked it up.
Alright, wait. So the Z-score is 0.90.
0.43.
Why do we round it 2 places? The chart only goes to 2 places.
My brain says 4.
I know. Make everything 4 places, and you're covered, right? Except for Z-scores, because the chart only goes up to 2.
I got a different answer.
Oh, okay. Dissension in the ranks. So let me see. What'd you get, Tessie?
I got, for the Z-score, the answer.
The Z-score. We haven't got the answer up here yet.
Oh, 0.88.
So yeah, I get this.
Oh, I see what I did.
Alright, so everybody cool with that piece? That's just the Z-score, right? So 0.90, so I'm going to put it right there for myself. So if I look up 0.90, I of course am going to get, real quick by the way, I'm going to say this, oh my god, Jeff. Anyway, I don't know what happened, somebody sat on my line. 0.90, doesn't that look like a probability? Doesn't it look like an area? 90%? But it's a Z-score, so always put Z-scores down, always put areas up. Every problem we've done, I've done that already. But you want to be nice to yourself. Again, you put things in the right place. So what do you get when you look up 0.90?
8159.
8159? 0.90, 8159, kick ass. 8159. So what's this going to be? What's the answer?
1841.
I think I told you this before. You can do this without a calculator. What makes that 9? 1. What makes that 9? 8. What makes that 9? 4. What makes that 9? I mean, sorry, the last one's 10. 1. Because if you make this 9, 9, 9, 10, that 10 would have to carry through. It makes the whole thing 1. And I know you got a calculator. What are you telling us that shit for, Jeff? Calculator does it. Well, we're the humans. We should know some stuff. All right, last problem. Same thing, same stuff. Well, what's the probability that it's between 60 That's 70. It's the same problem, same stuff. It was probably the scores between those two things. Basically, somebody got a D.
Is this the same area? Or
Same stuff, same situation, yeah. So both of these guys are down here, right? So both of them are gonna have what kind of z-scores? Negative. So when you do something, you gotta make sure it makes sense what you get. If you get a positive z-score, you should go, well, shit, I did something wrong. Just made something. And real quick, guys, how long have we been doing problems like this? About an hour. So if you're not quite getting it yet, okay. We're gonna do more of this stuff, right? I'm just hoping that some of the stuff seep in your head a little bit. Alright. So I want to use the z-score chart. Why am I allowed to? Why am I allowed to use the z-score chart? Normal curve, I like it. So I can use the z-score chart if I make these into z-scores. That kind of makes sense. So how do I change 60 into a z-score?
60 minus 71.3 divided by 15.
I like it. So what always has to go here in the z-score formula? Always. The mean. Always. The mean. I like it. So what the hell you get there?
0.745 negatives.
So negative 0.75, rounding.
Yes.
Okay.
Oh, so you were rounding second?
And this is a wonderful, for example, real quick, I know we finished this problem, but a lot of times somebody will write this formula down, they'll get that number, they'll circle it, and they'll keep going. But that's just what I said earlier. That looks like 90%. You gotta tell yourself what the hell you're doing. What does this formula result in? A z-score. So have you answered the probability question yet at that point? No. So right here, round it to two places because I know it's a z-score. What do you get when you look up negative 0.75? Negative 0.75. 2266, I like it. So I'm going to put that right up here. What was it, 60? 2266. Trying to be very nice to myself. Problem's already me. I should be nice to myself. Now I'm going to do that whole process again for 70. So what's the z-score for 70? I think it's 0.06. What is it? 0.08?
Yeah.
6? So 09, right?
Yeah.
Negative, right? Is that right? You guys got that?
Yeah.
So this is negative, I should put this underneath here, negative 0.75. Negative 0.09. So what do you get when you look that up? Negative 0.09.
0.464.
Yeah, this is way here. Way negative way over here. 4641. I like it. So then how do I answer this crazy problem? Subtract. So 0.4641 minus 0.2266.
Seriously.
2375. So a 24% chance, almost, that somebody made a D on that test. Yes, sir. Oh, two. This would be 4, but I'd have to borrow there, right? So it's just doing the same thing, just real quick in my head. That's all. I could have told you, in Tibet. No, I didn't. I learned my subtraction techniques. All right, I think that's enough. Yes.
Your graph real fast.
Oh. Don't forget your IDs and stuff. Dear God. Please.
We found ours. I found mine.
Oh. Okay. Thanks. All right.
The owner.
Yeah.
Oh, you need the grade back for these?
This year, yeah.
How about you want the grade?
No. This is just somebody that hasn't gotten there yet.
Wait, can I just take a picture?
That's 6162. Oh my. So we're obviously gonna, I want to give kind of an overview, and we're gonna kind of start over at the beginning again with the handout.
I was starting to think that was negative thing, and then as soon as you started doing that, I'm just gonna forget about it.